So now we're on problem 39. And 39 says determine all possible digit replacements for x so that the first number is divisible by the second number. For example, 3758x is divisible by 2 if x equals 02468. Okay, so it's basically just using the rules that we have. So if we have 398,870 something, and we want to divisible by 2, what does this have to be? Well, to divisible by 2, it just has to be an even number in the last digit. So it's 02468, just like the example that they give. 42, 2,143,890 something. And we want it divisible by 5. Well, for it to be divisible by 5, it has to be either a 0 or a 5. So we have 90 or 95. 45. Find the number of divisors of each composite number. Well, there's that rule. And if you go to the rule, it says where's the rule? Oh, actually, it's written in the book here. So what we do is we do a factorization of that number, 42. So let's do that. So since it's even, you divide by 2. That gives us 21. It's not even, so it's not going to be 2. Can we divide it by 3? Yes. And that leaves 7 over 7. And so 7 times 3 is 21, times 2 is 42. So we have, this looks, 42 is equal to 2 to the first times 3 to the first times 7 to the first. Now what we do is we take each exponent, which is 1, and we add 1 to each. So we get 1 plus 1 from this exponent. That equals 1, 2. From the second exponent, we do the same thing. 1 plus 1 is equal to 2. And the third one is 1 plus 1 is equal to 2. And then we multiply these things together, which would be 2 times 2 times 2, which is 8. So that says that there are 8 divisors in terms of 42. Well, let's just see if that's true or not. So what we'd have is 1 and 42. We would have 2 and 21. We would have 3 and 7. So that's only 6. So what's going on here? So that's 6 divisors. So what did we do wrong here? If we add them, if you took 2 plus 2 plus 2, you get 6. Okay, let me just check here. I'm going to read the solution manual, see what I did wrong in my thought process here. So it says 8. Okay, so what am I missing out here? Let's see, we have 1, 2, that's 42, 2 times 20, that's that. 3 times, oh, yeah, we had 14. Actually, that's where it is. Okay, just didn't get that right, did I? So 3 and 14 are the, 3 times 14 is 42. And then you have 7 times 6, so that is 8. Okay, so those are our divisors. 1, 2, 3, 6, 7, 14, 21, 42. 42 divided by 1 is 42. 42 divided by 2 is 21. 42 divided by 3 is 14. 42 divided by 6 is 7. 42 divided by 6 is 7. 4 by 7 is 6. 42 divided by 14 is 3. 42 divided by 21 is 2. 42 divided by 42 is 1. So that all works out okay. Let's do another one. I think I have 48 as an example. So 48 is 2 to the 4th times 7 squared times 13 cubed, which is some big number. Let's go ahead and multiply that just to see what it is. So we don't really need to know, but let's see, 2 to the 4th times 7 squared times 13 squared. It's 132,496. Okay, so how many factors does that have? Not factors, but divisors. So we take 4, which is that, add 1. That gives us 5. We take 2, which is that, plus 1, which is 3. We take 3 plus 1, which is 4. So those are the, and then we multiply them together. 5 times 3 times 4, that's 15 times 4, which is 60. So there's 60 divisors. And let's do the next one, 51. Leap years occur when the year number is divisible by 4. An exception to this occurs when the year number is divisible by 100. In such a case, the number must be divisible by 400 in order for a year to be a leap year. Determine which year is a leap year. So, okay, so the year 2200, of course, it's divisible by 4, but an exception occurs when the year is divisible by 100. So this is divisible by 100. You'd get 200. You get 22. In such case, the number must be divisible by 400 in order for the year to be a leap year. So 2200 divided by 400, well, you'd have how many times? You'd have like 4. That would give you 6, well, actually 5 times 5. That would give you 2,000. Subtract it, you get 200. Carry another 1. So it's actually 5.5, which is not a whole number. So leap years would be 2000, which was 2400, which we don't have to worry about, 2800, etc. So these are leap years. But 2100, 2200, 2300, those all are not leap years. And the final one, actually that was the final one.